would equal 4.12 amps. So let's take a look at, let's put a triangle in here. Notice I didn't put the triangles in here because I wanted to sort of get you guys to think in terms of what's going on here. All right, so we're kind of looking at it like this, right? So where this would be my IT. We said that that's 4.12. And this one would be my IXT, which is 1 amp. And then this would be my IR. And we said that was 4. Okay, so now we've got that amperage triangle. Now we can find our power factor and our angle theta from that. We can find our power factor and angle theta. So let's do that now. So step number 4. So power factor first. Power factor, we would say, in this particular case, IT over IR. Okay, so obviously we've got something. Hang on one sec. I just said that backwards, sorry. 4, my IR over IT. Looking at why do I have a power factor that's above unity? Okay, my apologies. So IR over IT. So 4 divided by 4.12, 2, 4.12, and we get 97%. All right, back on track. So 97% power factor. And what is the arc cos 0.97? The arc cos 0.97 would be 13.86 degrees. 13.86. Okay, and now we can find our impedance in the circuit. I'll go step number 5. Solve for Z, and Z is equal to my ET over my IT. So I've got 120 volts divided by my amperage total of 4.12 amps. Gives me a total of 29.12 ohms. 29.12 ohms. Okay, on to our powers. Okay, so let's go resistor power first. So true power equals voltage across resistor times amperage of the resistor. So I got 120 times 4. So I got 480 watts dissipated across the resistor. Step number 7. Number 7, let's go inductor. So my reactive power, inductive, my voltage inductive times my amperage inductive. And for that one, I've got 120 volts times 2 amps. 2 amps. So I got 240 VARs inductive. Okay. And then we can go with our capacitive. Step number 8. Reactive power capacitive, voltage capacitive, times amperage capacitive, 120 times 360 VARs capacitive. All right. Now we can find our total reactive power. So if I was to put a triangle in here just to visualize it, again, you guys don't absolutely have to do it. Oops. But I find that it does help to, sort of visualize these. I'm just going to flip that. Okay. Whenever I'm doing these, I always start off with my, oops. Hang on. I got to flip that. All right, that's better. Okay, so I would, on this one, I put my watts, my true power here is 480 watts. And then this one, I'd have my reactive power total. So what we're going to do is we're going to take our reactive power capacitive and subtract it from our reactive power inductive. So we'd end up with a total reactive power of 120 VARs, and it's capacitive. And then my parent power, so step 9, I'll put over here. Solve for parent power is equal to this old thing, true power squared plus my reactive power total squared. End up with 494.77. Yay. 494.77 VA, volt amps. So we'll put that up here. So not too bad, right? Not too bad to do these. I'm not sure. I think sometimes even, doing these series ones, the series are almost more difficult than the parallel ones. But I've always said that even about just standard, circuits that we do in level 1. You can always check. And you say, well, let's check my ET. My ET should be equal to my IT times Z. And yeah, we've got that. We can do a check. My apparent power, we could say my apparent power would be my voltage of 120 volts times my amperage of 4.12, which is right. So 120 times 4.12 gives me 494.77. So I actually give you, I did it here just as a check, just because I like to check my work. I got 494.4. So, I mean, it's pretty close, right? I mean, we're talking about, some pretty close numbers. So just using that as a check, right? So